Let's continue with the slope fields homework. This is problems 4 through 6. So let me read the directions again for 4 through 6. It says find the general solution first, then find the specific solution that passes through the given point and state the domain of that solution. So we also need to fill in and sketch our slope fields as well. So let's look at 4 through 6. So number 4, we have our differential equation is dy over dx is equal to 1 over y. And if we want to start slope fields, let's pick some obvious things here. We see that there's only the derivative is only going to be, the slope is only going to be determined by the y value. And look at the location of this y value. This y value is sitting in the denominator. So we know that there's not going to be any slope where y is equal to 0. So if you look at the graph here, we know that y is equal to 0 on the x-axis. So we can pretty much leave all these order pairs blank because where y is 0, we're not going to get any real number with 1 over 0. Okay. And if we plug in 1, y value of 1, then all these order pairs have y values of 1. Okay. This differential equation is not going to be looking at the x values at all. So if y is equal to 1, then 1 over 1 is simply 1. So our slope is, so we just draw these short line segments to represent slope of 1. If we plug in 2, then 1/2. So the slope will be less and less steep. Okay. Down here, when y is -1, 1 over -1 will be a slope of -1. And 1 over -2, so -1/2, we have negative slope, but the slope is going to be less and less steep. Okay. So now let's see if we can solve our differential equation. Separate the variables. Let's get the y's on the left, the x's on the right. Take the integral of both sides. Integral of y is simply going to be y squared over 2 is equal to x plus c. At this point, we can plug in the ordered pair. I'm going to go ahead and find the ordered pair at this point. So plug 3 in for y, 3 squared, so I get 9. Plug 1 in for x, and I get 9/2 minus 1, which is equal to 7/2, so that's my c value. And then once I have my c value, I'm going to plug that in and take the next steps to get y by itself. So multiply everything through by 2, so I get y squared is equal to 2x plus 7. And if I solve for y is equal to plus or minus square root of 2x plus 7. These are two separate functions, and we want to determine which one will be the one that will satisfy this order pair 1, 3. So if I plug 3 in for y and 1 in for x, then it should be obvious that I'm going to be choosing the positive, right? This is the only one that will make sense. If I plug 1 in for x, I'll get 2 times 1, which is 2. 2 plus 7 is 9. Square root of 9 is 3. So positive 3, this one will make sense. Okay. And if we sketch our graph, the square root of 2x plus 7 will look like this, where it starts at 0, and we see that this graph in your calculator is going to resemble what you see here. Okay. However, when we find the domain, we have to keep in mind the restriction from this differential equation. So this differential equation says that we can't have a y of 0. If we have a y of 0, then that is going to be where the differential equation is not going to exist. So we have to make the adjustment based off of this restriction. So we know that y cannot be equal to 0, but we can have the graph reach every point until this, this specific x value. So if we want to find where this open circle is, then we can simply replace 0 in for y and solve for x. When we solve for x, we're going to square both sides. We get 2x plus 7 is equal to 0. 2x equals -7, so x equals -7/2. So we know that when we have a parentheses at -7/2, we know that the graph cannot exist there, but any point to the right of -7/2, then the graph will start existing. Okay, number 5, we have dy over dx is equal to xy over 8. Now, if we make some observations here, we see that when x is equal to 0, then we get a slope of 0 because 0 over 8 is 0. And anywhere that y is equal to 0, that is also going to be where we're going to get 0 over 8, which is 0. So what that means is everywhere on the x-axis as well as on the y-axis, we're going to get a slope of 0. Okay, so I'm going to have all these short line segments here representing slope of 0. Okay. And everywhere else, I'm just going to see that as long as I have a positive slope, ordered pair in the first quadrant, I'm going to get positive slope, varying degrees of positive slope. So for instance, here I have 1, 1, so 1 times 1 over 8 is 1/8. So very shallow, a graph that is not very steep. Now, as we get to larger and larger numbers, let's say 3, 2, okay, then we're going to get 6 over 8. So we're going to get steeper and steeper as we get further and further away from the x-axis. Let's say we're plugging in 10/6, right? 10/6 would give us 60 over 8, and that's going to be a very large number, very steep slope. Anywhere in the second quadrant, we're going to get 1 positive and 1 negative value, so we're getting a negative slope here. Positive slope because both x and y are positive, and negative slope here because x is positive and y is negative. So we just go through and do a rough sketch of our of the slope, and we're going to see a pattern that's going to show up. Okay, let's go through and separate the variables. Okay, y is on the left, x is on the right. Once we have that, we take the integral of both sides. The left side is natural log of y. The right side is power rule. Exponentiate both sides, and we reduce this to be y. On the right side is e to the x squared over 16 times e to the c. So we can take that constant, pull that in front. And now we can find our c value to find our specific solution. So plug 0 in for x, plug -2 in for y. -2 is equal to c times 1. This is equal to 1. E to the 0 is 1. So c is -2, so we have our specific solution. Y is equal to -2 e to the x squared over 16. Okay, if you plug in your calculator, then you get a graph that looks something like this, and that is going to resemble a shape if you just follow the flow of the graph on your slope field. And if you look at this function here, there's no restriction for this parabola, so our domain is -infinity to +infinity. All right, number 6, we're going to separate the variables. So we get dy over y is equal to dx over x. We actually saw a similar problem like this, well, actually the exact same problem on the notes. We see that when x is equal to 0, we're going to get slope of 0. Okay, and when y is equal to 0, then we're going to get where y is equal to 0, then we're going to get a slope of 0. So here, these should be filled in with slope of 0. Okay, and anywhere on the y-axis, we're going to see a slope of 0 as well, because this is where x is equal to 0. Well, actually, when x is equal to 0, we're going to see that's in the denominator, so we're not going to get a slope that exists there. Okay, and these are all going to be varying degrees of either positive slope here, negative slope, and negative slope. Okay, let's separate the variables. Once we do that, then we can take the natural log of both sides. These are both going to be 1 over u, so natural log of y is equal to natural log of x plus c. Exponentiate both sides, so we get y is equal to e to the natural log of x times e to the c. This is a constant, pull this in front. Y is equal to c times, this is x. So we have varying degrees of this linear functions here. Okay, so this linear function, we can plug 3 in for x, negative 6 in for y. So negative 6 equal to 3c. Solve for c. C is negative 2, so y is equal to negative 2x. So this is what negative 2x looks like. However, we have to sketch the graph through the ordered pair, 3, negative 6, and we're going to stop wherever the graph shows the sign of where it can't exist. So we know that the graph can't exist at 0, so this is going to be the first point at which it stops. So we're going to stop the graph here, and we're only going to graph a continuous portion of the graph. So it'll stop here, but it'll continue to the right. So if we want to find the domain, we just look at the graph. The graph starts at 0 with the parentheses, and it's going to go to positive infinity. Okay, the y value is decreasing, but the x value is increasing because this graph is moving to the right. So domain from 0 to positive infinity.